Hello friends, welcome. Let us take a case in which we are going to calculate economic lot size or batch size instead of economic order quantity. In manufacturing concern, or say in a factory, the production is generally made lot wise or batch wise, and in such factories it is necessary to calculate or to know the economic batch size or lot size. Let us first read the question. A manufacturer has to supply his customer with 24,000 units of his product per year. The demand is fixed and known. Since the unit used by the consumer is an assembly line operation and the consumer or customer has no storage space for the units, the manufacturer must ship a day's supply each day. If the manufacturer fails to supply the required units, he will lose the account and probably his business. Hence, the cost of shortage is assumed to be infinite and consequently none will be tolerated. The inventory holding cost amounts to rupees 0.10 per month, but in formula we need it on annual basis, so you have to multiply it by 12. So ultimately the cost of holding or carrying cost comes to rupees 1.20 per unit per year. And the setup cost, instead of ordering cost per order, where there is necessity of calculating economic lot size or batch size, we have to know about the cost per run or per batch. It is exactly like cost per order, ordering cost. Setup cost per run is rupees 350 per run, per lot, per batch, all are same. Find the optimal lot size or batch size or run size and the length of optimal production run. More or less the calculations are of same nature. Let us perform. The first we are going to calculate economic batch size, batch quantity you can say, economic lot size or economic run size. The formula will be same. Economic batch size equals to 2D into CO divided by CH. Let us substitute the figures. 2 multiplied by 24,000 multiplied by 350 divided by 1.20 and square root of the entire function. The economic batch size or economic batch quantity comes to 3,741.66 units. That means the manufacturer should determine each and every batch of approximately 3,742 units. Now the number of batches or number of runs per annum. Number of batches or run or lot to be manufactured per year. That will be N star, and N star is demand divided by Q star, where Q star is exactly EBQ. 24,000 divided by 3,741.66 or say 3,742. So it comes to approximately 6.41 lots or batches or runs. During the year, the manufacturer should produce this much number of batches of this quantity. Next is optimum run cycle time or batch cycle time. Optimal run or load or batch cycle time. That is nothing but our T star. T star is Q star divided by D, that is 3,741.66 divided by 24,000 The same comes in number of years, so let us multiply it by 12. So we can have now number of months, and it comes to approximately 1.87 months. At every 1.87 months, the manufacturer has to produce this size of batch for supplying the goods to the customer. Total variable cost. TVC star. Total variable cost, the same concept is there. Since we are going to calculate the total variable cost on the basis of EBQ, the formula with square root can be used. 2 into D into CO into CS whole square root. 2 into 24,000 into 350 into 1.2 and square root of the whole product. It comes to rupees 4,889.99. 4,889.99. That means approximately it is 4,890. Since we have no information about the cost, and in this kind of problems which require calculation of economic batch quantity or lot size or run size, we don't require to calculate the total inventory cost. So this was the case of calculation of economic batch quantity or economic lot size. More or less the calculations are similar. That's all. Thank you very much.